Okay, now let's welcome Henrik.
Thank you very much, and good morning. So Budgetpedia is a volunteer project fostered by Civic Town Toronto, and our mission is to make the Toronto budget more accessible to the people of Toronto to promote better informed debate. So I don't have very much time. I'm going to go through a lot of material fairly quickly, but touching on taxonomy is the place of that in developing the Act, data preparation, and the stability of reactive programming, which has worked out very, very well for us. Just a bit of background, we started in July of 2015, went through a development phase of about a year. Lots of people were involved, and now essentially we're going through a second phase of development, so what you'll be seeing is the first phase. So before, you see that? Before I go into the slides too much, let me just see if I can get this to, oh, it's not working. Oh, there we go. Okay, you can check this out anytime, budgetpedia.ca, just go to the Explorer, and what you'll see first is a chart that shows Toronto's 2017 budget, about $12 billion. The point is that it's interactive, so you can drill down. So let me just go down to Parks and Rec, for example. At any point you can get access to the city's detailed budget information. You can look at the what we call the taxonomy, or the classification scheme we use for this particular view, and one of the innovations is that you can switch those out. You can look at the source documents that are available. You can look at various kinds of views of the data, chart views of the data, including timelines. Lots you can do. You can take off the inflation adjustment. It's no fun when you don't see the animation there. You can prorate it in various ways. So per 100,000 people, you can switch to from expenses to revenues, or to staffing, there are quite a few views that you can take of this data. So I'm just making the point that there's quite a bit of functionality here that we were able to add to it. So what did we learn from the first release? Well, because we have this method of having a taxonomy stuck on top of the data from the city, we're able to switch it out and iterate and learn how to better present the Toronto budget. So what we've come up with for this iteration is dividing the budget into general services used by everybody, citizen support services, which is helping people in City Hall. So just to give you a taste, this is what it looks like. So general services, about $5 billion, consists of utilities, services for moving around, and public commons. So that's fairly easy to understand. Citizen support services, the familiar emergency services, health and education, income and housing, that's also fairly easy to understand. And even the inscrutable activities at City Hall can be categorized with general management, planning and development, civic enforcement, which have specialized functions, and that leaves internal services. So the point is that, you know, there are ways that that we can better get at how to understand and work with the Toronto budget. So we feel we have a good foundation for improving visualization, education, and engagement moving forward. So how do we do that? Unfortunately, we had to find a lot of documents and scrape them, which was horrible. And then we used fairly modern techniques for presenting the information, essentially reactive nested programming. So I'm just going to go through this quickly. There was a lot of work in scraping the data. The basic idea was to get simply the descriptions and the amounts out of the documents that we found. And we left behind the categorizations that the city had. That made it easier to process the data, and besides, their categorizations aren't very good, frankly. So we used Tabula to scrape that data, did a lot of editing and regular expressions, but ended up with a lot of source files that were very simple to work with. And that was the start, and worked out pretty well for us. So then we added metadata on top of those files, which let us process or semi-automatically those files to get sort of a data set that we could work with. And then we were in a position to add codes. Remember, there were just descriptions there, so we had to add codes for each of those lines, and then impose continuity. So categories in the past would become obsolete, and they had to get reallocated to current categories in the city so that they could be compared. So that was actually a big deal. And then finally, create JSON files that we could readily import. So we wrote some code to semi-automate that. There's a couple of thousand lines. Starting with automatically generating a list of descriptions and then manually adding codes to these things. None of this should be necessary. We should be given all this by the city, but we're not. Anyway, then resolve those issues, then write the codes back to the source files. Then we were in a position to automatically get a list of obsolete categories and reallocate those to current categories. The result being that in the end we ended up with, after all this work, with identical CSV files that we could input, and that helped provide the base. Then we added metadata to the JSON files, assembled inflation, data, population, etc. And finally came up with essentially fairly clean JSON files after all that processing, and that was the goal, and that gave us the flexibility to continue. So the result is we had a lot of input files and very few very nice clean JSON files. But we still just had a list at this point. Remember, we left behind the categorization, so what we wanted to do is be able to add hierarchies in the top to be able to represent this stuff and make it more accessible. So that was the next step, is basically hand create some of these hierarchies. They're not too bad, they're about 30 or 40 nodes, so it's not that hard to do. And the idea is to get the base data and a variety of ways of looking at it and jam them together and then present them. So we did find that taxonomies plus base data is very expressive, so we feel at this point that we're probably able to get to import any budget data that we want. For the front-end tool set, we used essentially React and related tools, and that's worked out very well for us. The architecture was to decompose, so Explorer can have branches, branches can have nodes, and nodes can have cells and charts. And by the way, you can take any row over here and just clone it. So you can do something else with it, and then that way you can sort of take what it's got and compare with what you've got up there. So that was good. So it was made basically a matter of passing data down to these sort of detailed components. From the interaction point of view, we use this hybrid flux pattern, which is what React promotes and supports. And so basically there's an action, and it results in a change of state, and the change of state gets broadcast, which changes the local state, and then that causes re-rendering, and it goes around in a nice tidy circle. That's worked out very well for us. We identified about 30 actions. We did find that because it was such a complex page, it was flooded at one point. It was degrading into 4 or 5 seconds, so we did actually have to filter out. I mean, React is awesome, but one of the skills I have is to take technology over the edge. But anyway, we were able to filter some of that out and make it work. So that was about 8,000 lines of code, not too bad. So again, the lessons that we took from all this is that taxonomies are good. Methodical data preparation is important, and React Flux is stable. What we're getting into next is we want to get better data, obviously from the city if possible, through open data. And we want to improve the user experience. We're just starting here. The users have told us they want visualization, education, and engagement in very fulsome ways, so we're working on that for the next version. So there you go. I'm going to be around if anybody wants to talk about this, or if you're a React developer looking for a hobby, by all means get in touch. Thank you very much.